Okay, year 12. For today, we're going to be looking at exercise 3I, which is on modelling with sequences and series. Like, modelling is a really key part of the A level you are doing. It's about interpreting stuff in context, and it's something that students often find quite difficult. So please make sure you kind of watch this video right till the end and have a go at as many of the questions in the textbook as you can. Okay, so year 12, when it comes to modelling with sequences, anything involving compound changes, so things like bank interest and like percentage decrease over a number of years, will form a geometric sequence. And then, like, if you add them all together, you'd get a geometric series. We can use, therefore, some of the formulas that you already know to solve problems. Okay, so here's an example of the kind of question you might get year 12. So Bruce starts a new company. This is his profits for year 1. He predicts those to increase by £5,000 each year. So in year 2, 25,000, year 3, 30,000, and so on. He predicts this will continue until he reaches £100,000, and then he models those annual profits to remain at £100,000. We want to calculate the profit for the first 20 years. Fine. So for part A then, let's just begin by thinking about what we've got. The first term in our sequence is 20,000. The second term is 25,000, and so on. And so what this is forming is an arithmetic sequence, and it's arithmetic because it's increasing by a common difference each time. So then, to find the nth term of an arithmetic sequence, we use this formula. Then let's substitute in. A is the first term, so 20,000. And then D is our common difference, which here is 5,000. And then, what are we trying to get to? So we're trying to find out when his profits get to £100,000. Let's substitute in here 100,000. So then if we kind of expand, so 20,000 plus 5,000 and minus 5,000. I'm not going to go through exactly how you would solve the equation. You know how to solve equations, but when you do that, you end up with n equals 17. And so it will take him 17 years to reach these profits of £100,000. So now, because we want to work out his total profits, let's use our formula for the sum of an arithmetic series, which is substituting in. So we're trying to find S of 17. So it will be 17 over 2. 2 lots of A, so 2 lots of 20,000. N is going to be 17. Oh, so 17 minus 1. Let me just rub that out. And then D is our common difference, which is 5,000. And so then I'm just going to write up here now. When you input that, you end up with £1,020,000. Not yet the final answer though. Why is this not yet the final answer though? It's 20 years. We've only worked out the first 17 years. So there'll be an extra 3 years where he earns £100,000. So all we need to do is add on 300,000 to this answer. So we get a final answer of £1,320,000. Part B. Why might this not be a suitable model? Most reasonable answer, I think, to give is Bruce's profits are unlikely to remain constant year by year. Unlikely to, wait, let me rewrite the. Bruce's profits are unlikely to increase by the same amount year after year. Okay, now finally, part C. So Bruce's financial advisor says the yearly profits are more likely to increase by 5%. So if something's increasing by 5%, this is going to make it a geometric sequence. because it'll increase by 5% and then that amount will increase by 5% and that amount will increase by 5% and so on. So for geometric sequence, we need to write down our first term, A, and we need to write down our common ratio, which would be 1.05. That's how we would model a 5% increase. So using this model, we would use our formula for the sum of a geometric sequence. S of n equals A Rn, Rn minus 1. Shut that up. All over R minus 1. So in this case, we are trying to find the first 20 years still. And so then when you input that into your calculator, we get this. Which is obviously quite a bit less than this 1,325,000 figure. Okay, so different example then. This time we've got a piece of A4 paper, fine, it's folded in half repeatedly, and then the thickness is 0.5 millimeters. So work out the thickness of the paper after 4 folds. So let's just think about this. It's initially 0.5. After 1 fold, it will be 1. After 2 folds, it will be 2, and so on. We want to find the thickness of the paper after 4 folds, so this is going to be modelled by a geometric sequence. So for a geometric sequence, we need to write down A, which is 0.5. We need to write down our common ratio, which here is 2, and so then we use U of 5, and the reason it's U of 5, not U of 4, is after 4 folds. So this is after the first fold, this is after the second fold, and so on. And so then in this case, it is 0.5 times 2 to the power of 4, and when you input that into your calculator, you get 8 millimeters. Part B, so after 20 folds, that means we're going to be finding U of 21 for after 20 folds. And again, we're using AR and minus 1. So 0.5 times 2 to the power of 20. And when you input that into your calculator, you get this answer. And finally, for part C, state one reason why this might be an unrealistic model. And again, the most realistic thing to give here is it's impossible. Try it for yourself. Fold a piece of paper that many times. So for any of these types of questions, so give a reason why it might be unrealistic, you need to make sure you're relating it back to the context of the question. With that all in mind, give exercise 3I a go. It is quite a long exercise. So if you want to stop a little bit near the end, you absolutely can. But just making sure you are really looking at the mark scheme carefully and making sure your answers are in context.